But here we're thinking a little bit about this design. We're going to take this at the end of class and we're going to go cut it on the Gerber. We already loaded a piece of sheathing, which is the type of plywood. It's 30 seconds thick, and I've got an 1/8 inch down cut end mill that we're going to use to cut this out. And it should hopefully be a relatively easy cut. My hope, you know, if everything's working and I didn't screw anything up, although we did just change the dimensions, it should be like a less than 20-minute cut. And then when it pops off of the machine, it should be 2 little libraries that we can assemble from 1 sheet of plywood. And because all of these notches and dog bones and fits are all matched perfectly, in theory, then it should come together with no hiccups. And I've definitely, even if this one doesn't work on the first try, I've definitely had designs where I can reliably crank them off of a CNC machine like that, and you can have something that's just made. That's the entire premise of OpenDesk. The real trick is that I've got these sketches down here where I can go in and say, I'd just like to export this as a DXF and then save that as a DXF. I'm just saving them in a folder called Little Furry Libraries on my desktop. And then from there, I imported them into Inkscape where you can see, like, here's the layout, the footprint, and I'm working on getting those. I've just got to get, that's one of the top, one of the roofs, the other roof, the bottom, the 2 sides. I need the front and the back panel. And then I'll be able to have all of the design laid out. So we're getting close to the design work being done for that little library. That's with some touch-ups just here. But that's the skill that I'm hoping you would get to. This was an hour and a half of design work to go, and that's because I'm already good at Fusion 360. Don't get me wrong. That's because that's a skill that I've already got. It would take longer for anybody who's still learning the 3D design tools. But once you get more fluent in those programs, you know, it's not a terribly long distance from I have an idea, I want to make a thing, and then making it. And then making it repeatably is really the magic of the CNC. We're going to talk about CNC milling, make something big. So this is the goal for the week. This is, just to be clear, this is a good week to find a friend and start to imagine what it looks like to partner with someone for while you're working on things, because these can be big projects to take on. And so definitely start to think about how you want to do these pieces. But generally, we're going to go through this sort of order of what's up to try and explore these ideas. We're going to start off with 3-axis CNC and sort of define that as opposed to other types of CNC. We'll look a little bit at roughing and finishing, 2.5D designs, sort of like as a concept, dog bones and end mills, how those fit together, up and down spin, end mills, speeds and feeds, VCarve and Fusion 360, and then Gerber Safety at the end. So we're going to look at all of those pieces to try and bring all of this together. So first up, what is 3-axis CNC design? I've got a lot of moving things on this slide, and for that I already apologize. But the 3-axis is about the ability to move in 3 dimensions freely. And so here's a video GIF of like actual movement of a real end mill and a piece of wood. So you can see it can move back and forth. There's a little bit, you can see it get a little bigger, a little larger. It can move sideways, front and back, and then up and down. That's really the 3-axis that we're talking about. And so up here is a digital version of that. And you're getting sort of a hint of roughing and finish passes. But in order for this end mill here to follow that curve, it needs to be able to move in at least 2 dimensions. And then in order to make it around the whole sphere, it would have to be able to move in a third to make the full rotation. 3-axis milling is what we've got on all of our CNC machines here at MakeHaven. We don't have anything that's higher dimension. There is like 5 and 6 and 9-axis milling. We don't have those. That's where you can add rotations of the tool on top of it. So you can get really complicated overhangs and shapes and high-end stuff. If you can successfully design for one of those machines, you should go make money as a machinist. Just to be clear, you can make a ton of cash with a job like that. So you're saying the tool, like the end mill, do this and then do that? Yeah, the end mill for us is always straight up and down, more than 3-axis, and the end mill will start to turn around and do other dimensions and orientations for you. And we don't have those. A nice addition for one of our machines could be if we wanted to do 4-axis, so you just have like a rotation. Typically a 4-axis CNC, it'll rotate the cutting table, like a half of a rotation. So imagine you want to cut out of one piece of red oak, a propeller. You could entirely mill with a three-dimensional plan, one side of the propeller, and then a 4-dimensional CNC would flip the whole piece of wood over and then mill the rest on the other side. They're really cool, but they're not something that we have. So 3-axis CNC is what we're looking at. And it's just good to know that the others exist to sort of put this into reference. But roughing and finishing, when you're thinking about making something big, how do you make something big is a really important question for how you'd want to get there. I've made, and I've got it in the back, I made something that took me several hours, and Ruby helped babysit for a little bit. Thanks, Ruby. Helped babysit while I was doing this, but it was a long cut. It was maybe 3 hours of cutting because I didn't optimize my roughing paths. I forgot how much roughing is an important part of a design. But in roughing and finishing, this is something that's really important if you're doing fully 3D designs. And so this is actually the thing that I cut. It's that little spill tray. And I promise one day it'll be something that you can look at and make sense of. But you can see it's got like a taper to it. There's some fancy features and geometry. And if you're roughing and finishing, like ultimately I want this red shape, but my piece of stock, which is represented in Fusion 360 as a green block of your original material, it'll over time be cut into that shape. And so I chose to do a surfacing pass where you just make the top of the thing level. And then from there, you can do a roughing tool path where you use a wider end mill. And if you squint really closely at this, you can see that this is a wider end mill and this is a skinnier end mill. A wide end mill will take big chunks of material away, and it'll do that relatively quickly. Even just doubling the diameter of your end mill, it goes at least twice as fast, right? And so a 3-hour operation can be cut down to an hour and a half, or you can make big improvements in that when you think about it that way. And then from there, these are sort of the results. I have an extra tool path in there that it's showing, but really you'll get this sort of like a stepped nature on a rough tool path where it's not exactly the shape you want, but it's close. It's in the ballpark. It's removed most of the material so that your smaller, more delicate end mills can just go across the surface and sort of work out the exact shape that you're hoping for. So in that setup, you start off with roughing and then you'll do finishing. This is a process that's great. It'll give you lots of detail. I've heard several of you talk about how you want to engrave faces and pictures and do artistic things in your CNC work. If you're going to do that, you totally need to work on roughing and finishing. And in VCarve, which I have pulled up over, over here, roughing and finishing exists in the toolpaths over here. There's this roughing, that's a 3D roughing toolpath, and that's a 3D finishing toolpath. So roughing and finishing are built right into VCarve. So those are totally there. If you have a 3D model that you bring into VCarve, it'll do a lot of that legwork for you, which makes it really, really handy. Fusion 360 also has these features. It's just it's not quite as clean cut as VCarve. I think VCarve is slightly more beginner friendly, but we'll talk about the two more in depth later. This as a concept though is worth it to at least have looked at so that you can know you'd come back to it. But the big thing that I think is going to be the main highlight for the week for us is going to be talking about 2.5D designs. And that's really the hope that we get to play with that a little bit today, a 2.5 dimension design, which is a funny thing, right? If 3D is being able to move up, down, left, right, and front, back, 2.5D is really thinking about 2-dimensional motions like the laser or the vinyl cutter. Those are 2-dimensional CNCs where they move just across the surface. There's not really a depth to the laser so much. There's not really a depth to the vinyl cutter. They just trace out drawings. That's a 2D machine. 2.5D is where you're mostly just, the third dimension is just like ancillary. It's just an extra piece. You use it to raise the end mill up or to put it back down, but you're not using sort of the height as a feature. Whereas here, to make a half of a sphere, really I need to make little steps in all 3 dimensions all the way across the thing. In roughing and finishing, I'm making steps in maybe all 3 dimensions at any given incremental point. But for 2.5D designs, I'm making designs that are built out of big sheet things. So I'm taking a sheet and I'm just making cuts like you would on the laser or the vinyl cutter, just much, much larger. And so 2.5D is a structure, a way that you can design and build so that you can use sheet goods really effectively to build all sorts of stuff. This is a table that I actually have made in the past. It's a 2.5D design. All of these models I'm more than happy to share with all of you so you can play with them in the like Fusion 360 model thing. This is all from one sheet of plywood. It cuts in 10 minutes and it's just one sheet of 3/4 inch plywood. That's it. And then you get a table in less than 10 minutes. It pops right off the CNC. This is a cart that takes a sheet and a half of plywood, but it's a cart that you can roll around on casters and has doors. This, some students of mine designed to carry around equipment for a fab lab because we were going to put it all onto a bus so that they could drive the bus from elementary to elementary and have like vinyl cutters and laser cutters at elementary schools on a bus, which is a fun project. This is 2.5D design on the laser. For just smaller things, this is a tempeh incubator. This is the stool. So if you did the stool design project, that's totally 2.5D. It's 3 sheet pieces that slot together and you get a 3D object at the end of the day. And then this is another good example of something that's interestingly 2.5D. It's a ramp. You can see this little car rolling down the ramp here. The car is also 2.5D. I really love this technique. But on the bottom, oh yeah, this is a tempeh incubator. So you can grow your own tempeh. It has to be kept at a constant 80 degrees, which isn't a problem, like where it was a natural cuisine in the South Pacific. But in Cleveland, that was just not going to happen. So that's an old 3D print bed, and there's an Arduino tacked on the bottom. The 3D print bed would just hold it at 80 degrees for like 4 or 5 days and let the tempeh mold grow in between the soybeans. Yeah, it's fun. That I left in Ohio. I physically have this. It's just back in Ohio. This ramp comes from 2 sheets of, or it was 3 sheets of plywood. The middle one might be MDF. And these are just vertical things. This one's got a curve to it. It's actually a fascinating design. If you really get fancy with this, we put in a whole set of relief cuts so that 3/4 inch material could be bent, just like when you did laser cut kerfs. If you played around with this, the same thing works on a larger scale, and you can do 2.5D where you build in bending features for it also. So like this is a full sheet of plywood that was bent to make this ramp because the kids that I had at the time wanted a car to go down a ramp and then be able to spin and go on the floor as fast and as smoothly as possible. And that was the method that we got to work. So putting some relief cuts in a sheet of plywood will make it surprisingly bendy. And every so often you can find that in like usually on the underside of tables, if you have an apron on a rounded table, you might see curves where people used a table saw to cut little relief kerf cuts so they can bend the plywood. It's totally a thing you can do. This is definitely a more advanced thing. And in Fusion 360, I designed this as a piece of sheet metal. You just lie to Fusion 360 and tell it's a piece of sheet metal with 3/4 inch thickness and give it some weird parameters. You can totally make this happen where you're bending plywood with relief cuts. If you're interested, we can go a lot deeper with that skill. Yeah. Oh, you have to lie to Fusion 360 because let me go into Fusion 360 right here. And I can actually let me pull that model. So in here, you have to lie to it because in sheet metal, it has all of the parameters for bending metals, right? And so it doesn't necessarily know that let's see, Science Olympiad, and then these events, and then here's our gravity vehicle. So it only has certain materials that it knows the parameters preloaded for, like aluminum or steel or whatever. And so if you want to make a sheet metal design, like in here, for this to work, you're going to have a whole separate set of tools, and let's see, here's your sheet metal rules. So it has preloaded sheet metal rules. Oh, must be MDF. where there's a K factor for the metal, there's a thickness to the material, all these sorts of things can be preloaded in. So you have to like make your own new metal that is a piece of plywood in Fusion 360 in order for this to work. But it really works well, where you can get your material to bend. If you can look up what you want for dimensions, we sort of fiddled with it until it worked. We didn't have a great like structure or plan for this case. We just made like 4 or 5 of them until it didn't break. And so that's how we got these numbers. You can get really, like for the sake of sheet metals, you can get really intricate and involved. And I've got that as an example in here. It's coming up somewhere down, too far down in the line. You can do full sheet metal pieces where like this is all intended to be maybe 16th inch steel, and sheet metal rules will let you take this design, which was a phone stand, and lay it out flat. So you could cut it on the water jet and then mark out where you'd like to bend it also. So it's capable of handling all the way to that, but then you can bring it all the way back to 2.5D design for wood also. It's a neat feature if you're thinking about how to make things on a CNC. But one of the real strengths of 2.5D design in general, if you're thinking about how to make all these things and make them quickly, I expect that we'll see a lot more 2.5D furniture come into existence now that as examples, now that we've got a Gerber that's up and running. We're gonna see people want to make scaled models. When you have 2.5D things that you're gonna make out of sheet goods, the sheets that you're using are usually plywood of some thickness, right? But you can also take that thickness, and if all your joinery is designed and determined based on the thickness of the material, you can scale that down really nicely from, I think that this is 1.4 millimeters thick, the mat board that we have, 1.4, 1.5, something like that. You can take the 3/4 inch piece of plywood and scale it all the way down to mat board thickness, and you get little tiny adorable scale models of 2.5D designs, which is like cute in its own right, that they're just nice and small. I should have brought that one with me. But they're also really helpful for like practically working out the logistics of, do you like the shape? Does it work? This stuff is almost free. Cardboard is literally trash most of the time. You order things on Amazon, you've got a bunch of cardboard, and you can use it to build scale models for almost nothing compared to the plywood that you could buy that would be a far more expensive investment, right? A sheet of Baltic birch plywood from the back, a 3/4 inch sheet, is $90. It's very good stuff, but it's very expensive. And so and before the pandemics, wood shortage and all those sorts of things, there you go. Maybe you can, but it's not physically here. Yeah, there's cheaper Baltic birch, but you have to transport it on your own. I think that's the cost. It's pretty much the cost that Leor got it for, I think. And it's very convenient that it's here. So if you don't want to, if you want to pay whatever it costs here, then it's totally worth it, I think. And so in any case, regardless of in either way, it's still an investment. I'm used to Midwestern plywood for $35 a sheet. It's the markets are different in different areas. And that was pre-pandemic prices. So actually all of these things that were made in this demo, in this right here, these were all out of that $35 sheet plywood stuff. But before you make the investment in plywood, making a model is really, really handy. And all you need to do is take the thickness, the thick nye, the 2 material, and just do a reduction. Like you can do percent size in Inkscape. If you import your designs into Inkscape, which is what I'm doing here to try and get ready to build that little free library, all you need to do is hit Control A, grab everything, and then change over to percentages. And if I know what percent the thickness of the sheet of plywood my cardboard is, cardboard's typically like 0.15 inches. I used to buy it by the thousands of sheets of cardboard for the exact same thickness. So this would always work. It's a good trick as a teacher to have like a pocket trick to pull. And so I would buy lots of cardboard that was all exactly the same. And that cardboard was 0.155 inches thick. And I knew that off the top of my head. And the sheets of plywood that we bought were always 0.725 inches thick. So if you just did a fraction where you did 0.155 divided by the 0.725, you'd get some percentage. It was somewhere in the ballpark. I don't know what the percentage was. I forgot that. But you get some percentage and you could just reduce it in Inkscape or Corel or whatever, and you'd be able to go from the full size model or full size product down to a little model. And so you could do this and get little scale models of all your furniture. We'd regularly run competitions. This is a public school, so buying a sheet of plywood was a once in a while thing. So we'd have design competitions in a class where everyone made a cardboard model, and then we could cut out on the Gerber from the like one sheet of plywood we had to share. Right? It's amazing we had a fab lab and then plywood was hard to come by. But it is sort of a scaled thing that you'd have. But in here, the strategy for making models can be really helpful for a bunch of reasons. And I would definitely encourage, if you're going to do some design work this week, to make yourself a scaled model of whatever it is you want to make. If you're interested, it's the classic similar triangles math problem of like one dimension to another dimension. It's how you can judge the height of a tree, but without having to measure the tree directly. It's one of those like fourth grade math problems that's like just about too tricky for the kids that they're asking. So it's an interesting problem for sure. But if you're doing all of this design work and you're going to be building on a CNC, right? You've got all these cool things you want to make. You've got 2.5D design. You've invested a lot of energy into getting the curve on your piece just right. There's a few costs and benefits that come with building on a CNC. One of them that's really neat is that we can take and lay out all of the designs for this table onto a single sheet of plywood. And when it comes off the machine after 10 minutes of cutting, you can just pop it together and assemble it. And that's like a magic trick, to be clear. It totally doesn't make sense until you watch it happen the first time. But in order to make that work, you've got to deal with a few problems. Right? You can see I've got these little circles cut into all of these shapes, and maybe some extra space over here. Those have different features and purposes, but one of the big ones is CNC dog bones. If you looked at the stool, one of the things that we did in that stool design video is we added these dog bones in. When you use an end mill, a round cutting tool, you can't cut a perfectly square inside corner. I can cut on this circle, I can cut that corner just fine with an end mill because the end mill will go really slowly right around it, and it can stay tangent to that surface all the time. But if I want to magically take this design, pop it off the CNC, and then it just fits together, instead of getting a perfectly tight inside corner, I have to overcut that corner a little bit. You can either get it not perfect and then finish it with a chisel if you really hate this aesthetic. But I don't mind at all overcutting it by a little bit with a design here, or maybe here or there, all of these little dog bones, so that when there's a little bit of extra material cut away, the squared off corner of what I want to fit there just fits. I've got a little material that's been removed. There's a little bit extra that's been cut away, but to me, that's not a big deal because then they just fit together. It's totally worth it instead of the post prep. I've actually done it without dog bones on one project. And I learned my mistake in one project, right? After it came off the machine, none of it fit together. I had to go over it with a roundover bit everywhere on the edges of the piece, and it was terrible. And it'll inevitably happen to you, I hope, on a small project. Mine was a dresser, so it was not small. And you want to add these in. It takes a little effort, and it'll take getting it wrong a couple of times. Hopefully not on a large scale project. It's a good reason to do the models. But in here, these dog bones overcut so that things fit together nicely. You can do lots of pieces with that, and I guess I'm talking about dog bones here. So you've got this, where these dog bones are going to all be cut into place, and you've got all the little extras here. This is where a bolt would go on this, or a bolt goes right here, and a nut goes in right there. So I cut dog bones because I'd like that nut to go right up against this piece of wood. So I want to fit it in and have it be nice and square. It was a little extra tall, so I didn't have to worry about them on the top. Dog bones can go here. You can have them cut into a panel. So like this one kind of cuts back into that panel. This one's cut into a tab rather than the panel. And so these dog bones are design-wise a little different, but fundamentally doing the same job. Dog bones like this give you just that little extra space so that your designs all fit together. And then often, like in this drawing, it's talking about the radius. This is for a 1/4-inch end mill, and the radius is half of that. So the 1/4-inch end mill is the diameter of the end mill. The radius is half, so it's going to say that it's 0.13. But these different pieces are all something that we need to sort of look at. Another feature that's often true on a CNC project is that your materials that you're working with have you're going to do some computer controlled cutting, and those cuts are going to come out really nicely. But the thickness of your material, if you're doing 2.5D, isn't quite as guaranteed, right? I went and measured that sheet of plywood, and it said that it was 23/32, which is like 0.71 something inches. However, on almost any sheet of plywood, it's not going to be exactly that across the entire surface, right? And so there's going to be some variance across the whole thing. And so what you need to do in designs also, I add in this little tolerance with some extra space so that the holes are just a little bit bigger than they need to be. And up here, you can sort of see that there's a gap. We'll look at that a little bit closer. That little gap is there so that if the plywood isn't quite the right thickness, if it's a little bit too wide, or my end mill is actually a little skinnier than a 1/4 inch, if either of those are true, it gives me enough clearance that they'll still slot together nicely. It's an important trick, one that you can solve by sanding your tabs, but it's just another one of those features where you'd like to be able to have it all work just fine as soon as it pops off of the machine. And so this is a neat trick to be able to pull, to add a little tolerance in so that all of your stool will just fit together nicely. And so we've got these designs where we've got dog bones for the nut here, or these dog bones for the actual pieces to fit together. And those are features that we're going to look at. Now, a place that's mastered this, if you want to look at more examples than the ones that I have, OpenDesk is fantastic. It's some sort of a design collective. I'm not sure if there's a central designer, or I think you can submit designs to this as well. But then you can use a CNC to cut out their designs. And so let me just go to their website so that you can see sort of what kind of things they have to offer. These are like large 4-seat workstations. They have a 14-seat group table, these big, beautiful pieces of furniture that you can buy. Look at how much they're charging for that. For quotes, you can get a quote for this table. It's all made out of things that pop right off of a CNC. And so they've got lots of different designs and things. Here's a Finn bookshelf planter. So they've got these different things that you can get. Let's see, to request quotes. Let's pop over some of their designs, not all of them, but some of their designs you can allegedly download. I've been checking to see if I could download one of their designs for a couple of months now, and they seem to be always working to change their settings, so it's down temporarily. But let's see, if we go to this Johann stool, we've got this. Here it is, $69 for the estimate of price in sets of 6. You can request quotes, or you can go to download. And if you go to continue to download, they'll send you not the material, but they'll send you a design file like this, where those are all of the lines for the cut in one sheet of plywood. And all you do is lay that into the Gerber or into VCarve, and you say, I'd like you to cut right on those lines. And in theory, it would pop a table out of that sheet of plywood for you. Ultimately, their business model is we have these designs. You can either buy the designs from us or pay a local makerspace. And there's a bunch of them across Canada and Europe that do this, where you say, I'd like to buy one of these tables, and then a registered local makerspace will actually make it for you and then ship it to you, and you're paying them for sort of the service and management of the process of making it, but from an OpenDesk design. It's an interesting business model if MakeHaven wanted to expand, but you'd need to get set up with them. But they're really just using CNC machines like the Gerber to cut them out of a sheet like you can see here. I think that these are exporting SVGs, and the color coding on that makes me think it was designed in Rhino, just because it's not a design software that I'm familiar with, but an SVG or a DXF would both transfer nicely to any platform. So these should, in theory, if this was available, And you'll see this web page is about the download and how it works. These are the designs. If we go to download, continue to download, make it yourself. They're saying that they're making some changes, and they've been making some changes for months now. So hopefully one day that will really be changed. Maybe you send them your email and they'd be willing to talk to us. That'd be great. But this is not the only place on the internet where this exists. We have an entire book here about how you design CNC joinery from Make Magazine. And then there's tons and tons of examples online of how to do this. But there's some really good design inspiration that you can take from places like this in order to build stuff. And eventually you'll learn sort of the features of pieces like this so that you can do it. There's even a researcher in Japan who figured out how to automatically CNC plan Japanese joinery, which is I don't even know quite what that means, but it's like automated CNC joinery that's like designed by the machine itself. There's some really cool things out there if you're looking to get into the CNC woodworking space, for sure. But OpenDesk is a great example of all of those things. Some of them you can even try in augmented reality. They've gotten fancier and fancier as the years go on. But one of the things, if you're going to be building with a CNC, is you need to be able to think about CNC speeds and feeds and up and down bits. And we talked about this more when we did unit 11.1, sort of a almost comical long time ago. But in here, we did talk a little bit about speeds and feeds. I've got on this slide a whole collection of videos to try and put it together, but I also wanted to give you the short version of this, just as a reminder. Basically, for us, follow the instructions on the paper that Lior put together that are over by the computer. It'll tell you how to do it. It'll tell you what speeds and feeds you need. And you just follow those instructions for the Gerber and you'll be good to go. Follow the instructions that Lior pointed out in all of his training videos, you'll be totally fine. But the feed is how fast you move along the material, and the speed is how fast it spins. And then you've got downcut bits and upcut bits, and those vary in how they press the wood as it's making the cut. A downcut bit presses the wood fibers downwards, generally making cleaner cuts on top, but means they take a little bit longer because it's pressing to where it can't go anywhere. An upcut bit is definitely scooping away the material a little bit more effectively, but you run the risk of sort of scraping up the top of as oriented on the CNC. If you're cutting the bottom, then it doesn't matter. If you're cutting the top of your workpiece, then you may care about which one of those you use. What's up?
Any reason you want to switch like mid-cutting?
Yeah, absolutely. You could use a down, and there's compression bits that do that for you in a single bit, which is interesting. But a downcut bit across the top of your piece would make a lot of sense, so that all of the top fibers are cut in a way that they're not like turn into tear out, so they stay in place. And then when you get to cutting sort of the bottom of your piece, you can use an upcut bit so that all the chips come away. And they all get pulled up back towards the material for the exact same reason, but on the other side of the workpiece. Another good reason to use an upcut is it's much better at removing material. So if you're doing a roughing pass, I would recommend an upcut bit because it'll pull the material away quickly. And then you know that later you're going to come back with a finishing pass anyway. And so an upcut for a roughing pass is absolutely the way to go. Or if you're cutting a piece of material free, an upcut bit is also good. There's compression bits that are also really nice, that do a good job. They have an upcut at the bottom and a downcut at the top of the bit, which is kind of confusing to wrap your head around, but they work well at solving this problem of needing to switch bits halfway through. And also there's this fantastic Jonathan Katz-Moses video that watches these cut. If you haven't seen that yet, you should totally go watch it. Here's a video where Applied Science walks you through, and here's a Haas tip of the day video that I think I've linked all three of these before to you guys in the class, but it's worth a second look.
So down. You find those upcut and downcut bits like the investment then?
So that's a good question. And the short answer is we have a bunch of upcut bits here, and I buy downcut bits for me to use. Because those are going to be nicer, like finishing bits that I'm going to use most of the time. So I have a collection of, I have one downcut 1/4-inch bit, you guys can use if you want. And I bought a 5-pack because it was pretty cheap of downcut 1/8-inch bits. but that would be small, and an 1/8 inch downcut bit is like small enough that on the Gerber, it's just going to take forever. So yeah, it's a Shipoko size bit. It's totally a Shipoko bit. So the bigger of a bit you can deal with, the faster it'll remove material. So for roughing, I'd use a 1/2 inch upcut bit. For a finish cut, you can, if you want to go really high end, I'd use a 1/4 inch downcut ball nose, and that'll give you a really fine point of contact. You can get really delicate looks. It also takes a long time to get the most high resolution cuts. So it's definitely a balance of how much time do you want to spend versus how good does it need to be. Do you intend to sand it after? Then you don't need to get super great, because sanding will also smooth it, right? There's a whole collection of things that you want to bring into account. If you were a shop, not MakeHaven, and you have one of these things in your garage, maybe you'd want to load a downcut bit, and then you could work in the other part of the garage, let it run kind of unattended. You wouldn't do that here ever. But if you had your own garage shop at home, you could do that, work in the other room, and if you ever hear the bit snap, you know to go look at it. And if it runs for 2 hours, who cares, right? You're doing billing and paperwork, and that's it, but that's not what you do here. For us, you need to think about time definitely as you're doing this, because these can certainly get long. But how do you actually design this is the reasonable question. How do you go from I have an idea into making something is worth looking at. So we're going to talk a little bit about, oh yeah, I should make sure that I'm repeating questions. Sorry about that. We're going to just bring out these 2 major ways to talk about VCarve and Fusion 360. These are the 2 major ways that I've designed for them. There are other ways to design for CNC, but I really love VCarve for 2.5D, and I think VCarve loves 2.5D also. It's good at taking vector files and turning them into cut paths, and that's what I want to do by the time we get to the end of class today, is to make that into something that we can look at. So here's the example of the little free library. I took this 3D model, turned it into a bunch of 2D vector tool paths. This is it all lined up in Corel. And then here it is with those vectors brought into VCarve. And then along those paths, I'm able to open up and say, I'd like you to cut on the outside of that line. I want you to add in tabs here and here, and make all of the controls for those vector files run the CNC. VCarve does a really great job at this operation, and it's a place where it really shines up over and above Fusion 360 in my mind. Fusion, I'm sure, can do this somehow, but it is going to be a different workflow. This one I'm really comfortable with personally, and I think it's also not, I've taught high schoolers how to do this. You guys can all pick this up. One major downside to VCarve is that it will not work on a Mac. And so for anybody who's a Mac user, my sincerest apologies. There are computers here with VCarve on it. You can totally come in, plop down, and make it happen. It will take a little while, but your first designs, don't let them be complicated. Don't like try and make the fanciest thing in the world on the first pass. We want to do iterative practice so you get better and better. And that involves starting off with something that's like recreating Shipoko, but on the Gerber. So lots of you made reasonable Shipoko projects. Just scaling that up to the Gerber would be taking all those 2D vector files and bringing them into VCarve and then designing from there. Just trying to straight up recreate what you did in this new design space is a very reasonable goal. Fusion 360, on the other hand, can do almost everything. Even though it may not be as good at 2.5D, it can do a lot of things. And that makes it great. It also makes it a lot to look at for a beginner. Some people really like it. I think Ada has a great experience, or you really like Fusion 360's cam, right? Yeah, all right. So Ada's saying that yes, not everything about it is great, but some of it is really nice. I think that if I were searching the internet for tutorials, there's probably more Fusion 360 cam tutorials than there are VCarve tutorials. So if you wanted to, if that's the way that you're going to learn it, if that's the way that you wanted to invest, Fusion 360 will probably be a little bit easier to go after that way. Plus, it will work on a Mac. So if you wanted to sit around at home while you're half watching a movie and play with this, no matter what type of computer you have, Fusion 360 could be the one. It's got tons of different skills, whether it's designing roughing and finishing passes in 3D, whether it's sheet metal, just straight up sheet metal, whether no matter what you want to do, Fusion 360 is designed to try and cover all of those bases. So it's got a very broad set of skills. It's just learning how to manage all of that in the one software. So it is a lot. There's a ton of different things that you'd need to take into account to make this all make sense, but it is broadly useful. Even if you wanted to make something big with the water jet and metal bending, which would be a really cool project if somebody pulled off one of those for this week, that'd be really cool. So there's tons of options for how you can make big things, and Fusion 360 can hit a broader range. They also will do CNC lathe. Fusion 360, I believe, can handle multiple 5-axis CNC milling and maybe even higher. It can handle lots of things that we can't even do here. So there's a ton of potential that's in this software if you wanted to go really deep with it. But then, yeah. It's totally doable, and that's what this was. This was designing for the Gerber on Fusion 360, and I can show you what that looks like. Let me just pull it up and show you. So this is in personal building, bar cart, and it's this model. Yeah. Sure. We'll see what happens. It was auto-saved a while ago. So that's going to load, which might take a minute. But in Fusion 360, you can totally do this design work. You make a series of tool paths, like this is a surfacing pass, a roughing path, and then some finishing passes, and you do that workflow all in here. It is very Fusion 360, but there are lots of videos that show you how to make it happen. And the nice thing is that there's just an option that you say, I'd like this to be output for the Gerber. It doesn't say it's for the Gerber. It says ARCS G64. It's a little coded, EMC2 ARCS. But once you know what button to click, it'll just output it directly for the Gerber. And then you're good to go. So once you learn what secret button to press, it's not too bad. And I've got actually a image that I built with that info on it, so that you can do that design work. I'll post that into Foundations after class. Let's see, did Fusion pull it up yet? Oh, it's still, yeah. Okay, so the question was, Ruby's got an idea. She wants to make it in something. And so should you start in Inkscape or Fusion 360? I think you can do either. It depends on how much you want to use constraints in your design and like geometry. There's not really a ton of constraints in Inkscape, and I've grown to love those. They're like, this line must be collinear or tangent, all of those things I really love in Fusion 360. So usually I'll start to design in Fusion 360. But if you're much more confident in Inkscape, you can start off there. Not everybody loves the constraints and geometry stuff, but if that's totally your jam, I'd start in Fusion. If you're much more organic at drawing in Inkscape, I would go for it there and then work your way towards Fusion. You can import SVGs into Fusion 360. So if you have an SVG that you've made, you really like, you can import it directly in as a thing that you want to extrude, cut, do whatever with in Fusion 360. It's good at importing vectors. Yeah. This is still loading. Yeah. You totally can. You can draw in whatever thing you want and then import. I've really tied up my Fusion. This is another problem. Oh, okay, good. All right. But what's up? Oh, there it is. Yeah. No, that would be really helpful. This is my design. Let's see if I can hide these toolpaths. But this is the design that I have, where you start off, and in Fusion 360, you have to go in and you say like what your stock is. this is the piece, and then you have to define what your material is. The green material, that was the block of wood I was cutting it away from. And then you do a series of tool paths that sort of like cut away at that block until you get to what you want. And so there's a whole number of steps that you can run through. And this is maybe not, it's not like the world's best example, but it is an example of how you do this. And then each one of these, you just go through and you say, I would like to post-process this. And if I want to post-process it for the Gerber, the settings are just down over here. I would say that I'd like to run it on Linux CNC, EMC2, Linux CNC. And so you can choose these options. There's a whole bunch of settings that you can set up. And this is maybe some that I installed, but it is a pre-installed setting that you can get for specifically our Gerber machine. So you need to know what to click right in here for how to do it. And so those are all pieces that we can work on. But if you wanted to, if you're doing some design work here and you wanted to import, you can insert an SVG, a DXF. You can even import other parts. But inserting an SVG is a really neat way to take a design that you've made somewhere else and just bring it right into Fusion 360. And then it becomes extrudable, cuttable, doable for all those things. So. It's a neat trick. Kate, you can do all sorts of things. Yeah. There's really been a huge proliferation of Fusion 360 tutorials, and if you have a tutorial, between the tutorial and I'm sure that we can find you a workflow that will happen. So there's tons of ways to make this work. But let's say you want to make something big, right? That's the goal for the week. This is the title of what we're up to, make something big. And this is really fundamentally, it's two goals at the same time. It sounds simple, it's just 3 words, but there's 2 pieces to this. There's something that's a physically large project, whether it's a big mural on a window, which sounds wonderful, and I love to see the photo. There's something about that scale that's big, and then there's also something about stepping up your CNC skills. Right? And so I think that everybody within this week can move both of those needles forward. And I was asked a good question about, do they have to happen at the same time? And basically, no. I think that there's really a lot of good reason to try and do them together with a neat project, to make a stool, a piece of furniture, something that's reasonable. But if you really are committed to some idea that doesn't necessarily do those 2 things at once, working on both those skills is really important. But there's definitely struggles to making something physically large, size, cost, whatever, handling the stuff, just moving the sheet of plywood that we're going to cut later took 2 people. And then there's advanced CNC skills, and that's like learning how to use VCarve, learning how to do the cam in Fusion 360. Leveling up some of those skills is its own whole set of things. So trying to work on those 2, maybe with 1 project. The water jet also to level up on the water jet would be really neat. There's all sorts of things. If I were to make a suggestion, I would say really try and do something with CNC joinery, like the dogbones, where it just pops off of the machine and it magically works. If I were to give you like a suggested project, there's even there's a CNC furniture book over here somewhere on this bookshelf. You could open it up, find one of those designs, recreate it, and make it happen. Or watch the stool video, do that design, and cut it on the Gerber. That's a totally reasonable make something big. I think that those would be good ways to go. And the stool is a fun way to like have something there's lots of instructions. You can follow along with how to do it, and you have like a tangible thing at the end, which is fun. So that would hit to 2 parts of this goal for make something big. If you're going to use the Gerber, and I think that a lot of you will, there's a couple of important safety rules that I really need to make sure that I hit as we're headed in there. It is a machine that is nice and big, but if I were to rank it if I personally were to rank it in terms of danger compared to other things in the wood shop, I don't think it would be the very top. I think that the wood lathe actually has a pretty good chance of doing some serious damage, and it's kind of sneaky about it. Whereas the Gerber, you at least know, like you can shut off all the axes, you can do it one thing at a time. The lathe can get real bad real fast. I'd put it probably the Gerber between the wood lathe and the table saw, somewhere in that range, rather than being like the top of the heap, most dangerous dinosaur. Yeah, and the joiner I think is probably up there with the wood lathe. Yeah. We have a saw stop. Yeah, the saw stop's really safe. Right? My point is, yeah, I don't want to say, like, I don't want you to like fall asleep while running these other machines. I'm not saying that. but don't be afraid of the Gerber as the biggest, scariest guy in there. It is more of a gentle giant. You can shut off lots of things. You can be in lots of control of the machine. And it's only if you're really doing something you shouldn't be doing if it goes awry. Yeah, I think there's 4 emergency shutoffs, one on either side of, and one on the, and then I guess the one on the computer also. 3 or 4. There's 3. There's 3. Yeah, you can use all 3. Like, there's no problem with using all of them. There's also fences. And so this is the Gerber. I tried to make a little drawing of the Gerber in its space, right? There's the wall up here. There's the little column. There's this fenced area. Basically, for the Gerber, use the red motion interrupts every time you're hands-on with the machine. If you're touching it, the red interrupt should be on. It should not be able to move if your like hands are in or actively near the machine. If it's moving, obviously the interrupts have to be off, right? It's got to be able to move, so the interrupts have to be off. But then you should be outside the yellow barriers. So you set up those barriers so that nobody wanders in, so you don't wander in. And it takes some restraint. This was not the rule in the shop that I was used to, but I'm following this rule because it's important. It's important to keep people safe and to be a good role model. There were essentially no rules in my last shop, so it was whatever you were comfortable with. But here, I think that this is absolutely the way that we should sell this. Now, another thing is don't leave a powered up machine alone. You should not walk away. If you have somebody to babysit, that's good. It is a buddy tool, so you totally need to be in there dealing with a buddy. These are some common things you would do on the Gerber, and this is when I'd have the motion interrupt turned on. If you're changing the tool holder, the interrupt should be on. If you're changing out the thing that holds the end mill, the interrupt should be on. If you're using a wrench to change the tools in the tool holder, if you're like near the machine working on changing out end mills, you should totally do that. If you're playing with the collets, cleaning up the work area, the interrupt should be on. Adjusting the dust shoe height, the interrupt should be on. If the machine is running itself, you should be outside the barriers. If it's self-homing on position limits, you need to be outside the barriers. If you're manually jogging it with the arrow keys or with shift in the arrow keys, you want to be outside the barriers. If the Gerber's running G-code, absolutely outside the barriers. There's only one spot in the entire workflow where you may be near the machine while you're also directly controlling it moving, and that's when you're setting the Z height. That's the only instance, the one time where you would maybe need to be close to it while it's moving, and it would be under your control. It's not automated movement. It's movement when you press the keyboard to set the Z height. It is one instance. You should make sure that everyone's aware, and you should make sure there's a person in the room with you. Not a buddy far away, a buddy physically there. Someone beside you, just so that it's all managed. The spindle should never be on for that. You would not want the spindle on to check its height. And we're working on getting a self-calibration sensor so that this eventually will just be moved solidly into the yellow area and not need to be touching it. But for right now, temporarily, this is a thing that can be done very safely. You just need to be conscious of the fact that that's the moment when you need to be thinking about multiple things at once. Totally can be done safely, but that's the one place where it doesn't cleanly fit into either of those two categories right now. It will soon move into the yellow. We're going to get it there. So with this, those are the different operations that are important safety measures for the Gerber. But again, the Gerber is a very safe machine to operate. It has an element of danger, but so do all of the machines in this entire place. As long as you handle them with respect, do it fine, you're going to be totally safe. I've run a machine like this for years and had zero problems with it. So it can be done well. So what are the things that you should actually do, right? What could you do over the course of the week? And there's been more suggestions than this list. I think first you should get badged on the Gerber. And that can be kind of a long endeavor. If somebody's running a little behind and that's the only thing you get done this week, I think there's some nobility to that. Don't feel terrible if that's the spot that you're stuck in. I think you should cut a circle and a square on the Gerber as a test. Maybe when you run it independently, if you just want to design a circle and a square, and that's, you know, that's as much as you get to, don't feel bad about it. This is, remember, it is a class, but you want to make sure that you're working to the time and ability that you have. And if that's a big advance in your CNC skills, I'm all in support of it. You could recreate your favorite Shipoko project on the Gerber, which is going to have you thinking about how do you use this in VCarve or Fusion. It's going to get you thinking more about the software because you don't have easel anymore, which really solves a lot of problems for you. When you step back into VCarve or Fusion, you've got to think a little bit more about speeds and feeds and all of the logistics of making a machine run. So even just doing that, I think, is a noble goal. Building something with 2.5D design features, this is what, if this were Fab Academy, which it's not, that would be the expectation. You just, boom, make something huge. Make a giant piece of furniture, make something very large out of multiple sheets of plywood. That's not the goal for this week. That would be a very great final project. But it may not be something that you make happen inside of 1 week with limited experience beforehand, even among the facilitators who are just recently badged on the machine. And another one that would be really great is recreating or downloading something from OpenDesk, because they've got so many good examples. Or the Make magazine book of CNC joinery, which I thought I had pulled, but it's probably back on the shelf somewhere. There's lots of different examples of ways that you can build things, whether it's Kate's DNA table, the little free library that we're going to look at in a minute, or all of those different things that could be interesting to build. So there's tons of options for what you can do. And that brings us all the way back to here, that ultimately it would be great if everybody could get to a point where they can use the Gerber as sort of a fluid tool where you're able to think about this. Somewhere in Slack, if you scroll down through, I posted a set of design files so that we could make all of this just happen. Let's see. Somewhere in here, yeah, I posted some design files inside of Slack so that you can get directly to all of these different things. And so that there's a whole set of files that you can play with to make this thing happen. And it just lines itself up so that this can all be cut, right? This shape, if we take all these other shapes and we sort of make them go away, we don't want that. We don't want the bottom. We want to just look at that one wall. This sort of a shape to design is, even though it's just part of the whole thing, it's got just a few features, but that's enough that you can start to build that little free library from it. So starting to get to a point where you're designing this way is long and nuanced. If you want to see exactly how I built this, I recorded it and did it as sort of a stream of consciousness. It's not really edited. It's very long. It's like an hour and a half of me talking my way through this. Unless you're really at the end of Netflix, it's probably not worth watching. But if you wanted to see like how I'm doing it, I'm thinking about I'm trying to figure out how to put chapters in YouTube videos so that I can say like, this is where I do this part. This is where I do this thing. That would be very helpful. I don't know how to do that yet on YouTube. It's a goal. That would be great. That's a good goal for me this week. And so in here, we'd be able to take all these designs. The thing that I was doing was when we came in and started, I was exporting all of my DXFs, saved all my DXFs, and I was importing them into here so that I could do this and say file, import, and I'm just using Inkscape as an intermediary so that I can get all of my files in exactly where I want them. Now I said that's the top, the other top, the bottom. Oh, and I want the wall. This is the wall that I wanted. So we'll do this, and when you're taking this, I bring it into Inkscape just because I think it's a little easier to manage moving around the vector files than in VCarve. I have a love-hate relationship with VCarve, which isn't necessarily great, but you can play around with all of these sorts of designs and do this. Here I've got this one. You can do a copy paste and just sort of drag these things around, play around with them. All of this is really ultimately what's fascinating is that it's just a collection of vectors, right? All I've got for these designs is a set of vectors. And once you start to think about it that way, I'm just going to tell and this is that back, right? The only difference between the front and the back was that cutaway opening for where you put the books in and out. Otherwise, I made sure that those two were totally identical. And so in here, you've got all these different tools that you can play around with and use them to align, set up, and do the whole piece. I'm just doing this so that I've got, this is the same size as the sheet of plywood itself. When I lay these out on the sheet of plywood, it'll fill up about half of a sheet, and then I'll be able to mirror it and put another one on this side. So it'll really fit two little free libraries onto one sheet of plywood. And if all the stars align after class, we'll be able to cut these two out and they'll just like magically appear from that whole setup. If it works, I'm going to be very happy because it'll be the first time I've done it on the Gerber, and it'll be really neat to watch that occur. It may take longer than 20 minutes, but hope, fingers crossed, not more than an hour. So that's the goal. But with that, we're totally at 8:05. I should stop talking, and instead, you can totally have the mic for a second. Let me.
Let's get back to fun stuff.
All right, and so okay, cool. That is great. I'm planning on being in a fair amount this week. There's several loose ends to tie up. Also this week at some point, and I'm gonna work it out. Hopefully, if Bobby's still around, I can work out a time with Bobby, and we're gonna work ahead. Next week is gonna be composites. We've been saying that for a little while, but we really have all the pieces here. I got the word, and so we're gonna try and do an example composites, which is tricky. The short version composites are making materials out of more than one, making projects out of more than one material. A good example to shoot for yourself if you're unsure of what you want to make is to make a bowl. You know, make a bowl out of some fabric that will be turned hard, and then it's sort of like a hardened fabric bowl. If you're just looking for something, you know, relatively straightforward. If you wanted to make something that you then use as a form, you can totally do that. If you want stock for that, I have these two pine blocks that I made that aren't for a project. I don't know what they were for. I just had a piece of wood and made a block. You can totally use those if you'd like, but those are all sorts of things. A bowl of an old vinyl record and resin would be really cool. I think that you can actually melt the records into bowls pretty easily themselves, but you could cover it with like a fabric. Oh yeah, it's not food safe. I don't think the epoxy that we have is food safe either. We're not making, this isn't a cereal bowl that I'm recommending we make, but like where you put your keys, you know, that's sort of a bowl, right?
We definitely have that food safe epoxy that we use for the cutting board.
Yes, we have gotten, that's totally true. We've gotten food safe epoxy. The tabletop epoxy I think that we had was bar top, it had to have been food safe. I can't remember. Yeah. And so there are food safe epoxies for sure. If you were interested in doing that, there's tons of options, but that's sort of thinking about next week. When I get a time locked in to do the testing of composites, I'll keep you all posted so that the question was, can you use an epoxied piece on the Gerber? The short answer is yes. Epoxy cuts like wood. So if you wanted to cut through it like a piece of wood, you would be totally fine with that. There's many other ways to do that also, so it's just whatever, you know, we sort of pick through whatever you're thinking and we can make it happen. But show and tell time, just to see what you guys have been up to. Lots of you might have had a very similar experience, but you might have had other weird things happen this week or other stuff that you've made. So I'd love to hear about it from anybody who wants to go. You can come up to here if you wanted to hop in this way, or if you've got things that you want to share through a screen. Anybody who wants to go, be happy to make the right tech things happen. Anybody want to explain like what they thought of the whole DNA thing?
It was fun.
It was fun. Here's one run. I don't know whose these were. That was yours and Ada's. That's awesome. It's neat to see. And so it looks like one of you probably had one of the short mutations. One of you had the long mutation. And so the short mutation would have made it further. The long mutation didn't go quite as far. Or those were the controls. Okay. And then, yeah. Oh, here's like my DNA and Lane's. There's tons of cool things that happen from all of these. Like to be able to see your own DNA, right? To see your genotype laid out there in front of you is really cool. It's super empowering to see that you could get different enzymes to get different pieces of information is also really interesting, that this is definitely how they do some kinds of medical testing. To identify one trait or another is wild and fascinating, and that we can do it here. It's just so cool. There's tons of neat stuff going on.
This is our DNA race with Ruby winning with the big genes that we had. And it was fun. I had a really good time spending time with everyone and feeling all sciencey and using micro pipettes and all of that was really cool. It was neat to see.
It's such a neat process. Like the process overall is you feel very sciencey when you do it. I think it's heartwarming to be together in a room with people again. And it's nice to be together with all of you. I look forward to a future where we're able to be together more. And so this is going to be a week where we probably spend some more time together. Kate, are you rolling through? Oh, look at that. We did a great job documenting all of this. That is lovely. It definitely makes it feel very sciencey as we're running through all this. And those gels are really, I actually didn't run the second half of this. So what did you do to make it glow? Is that just under a black light? Or is it like some sort of a phosphor? Do you remember? Oh, yeah, the UV. That looks like yeah, that's great. Yeah, there's tons of cool things to this design and this ability. It's fascinating to see, and the fact that you can order. Well, a good question to ask Nora or Kyle would be what are other enzymes that we can get to cut our DNA in other ways and learn other interesting things about ourselves. There are some of those enzymes that you might be able to get access to would tell you things that you may not really want to know right away. Like we can do tests to see if you have genetic markers for one thing or another. Oh yes, and so if you're interested, on Thursday the 22nd, JR is going to be speaking about his experience with, I think, 23andMe and some follow-up questions, which will be fascinating, where you can learn more about how, by a relatively simple internet service, you can learn interesting things about yourself, your genetic background, and if you have any interesting information. And so there's all sorts of coolness to this bio stuff. There's tons of depth that you can go into to better understand it. And so there's all sorts of stuff. Let's see, I feel like I've still continued to talk even with show and tell. Anybody make any other cool things this week? Even if it wasn't bio? We took a lot of time with bio. It was kind of a big activity. And it's been good. Ruby made a picture frame. We've got some other things. All right, so there's maybe we sort of cut it on the show and tell. I went to the Catskills. It was really nice to be out a little bit that's my show and tell. I went to the Catskills for hiking, more away from people, but in a COVID safe sort of little break. It was a nice weekend. Aaron, what's up?
So my toilet light broke.
Oh
but
no!
I fixed it. So I went down this internet rabbit hole, and I feel like there should be like a maker law number 4 or whatever the number is, where it's like anything you make is going to break. Plan on fixing it at some point and leave notes for future you, unless you don't like future you, something fun like that. Anyway, so essentially all of the technologies that I had put in place to help get it to work right kind of fell apart. And the person who was like keeping up with the code to make it work had essentially run into like a major fatal error that had just caused pretty much every component that I used to break terrifically. So so I had to figure out using MQTT how to essentially recreate it with a different company's door sensor. And thankfully it wasn't like a huge to do, but in the process I learned a little bit more of how I could take more control over my electronics in my apartment and get away from relying on larger tech companies from necessarily like having an input or knowing about every single piece of the puzzle. So I think I've taken a step towards technology independence in my home this last week by just fixing a toilet light. That's right.
That's a big accomplishment to move towards technology independence, to like know, to be able to identify that problem, to know like what broke, understand that part of the system, and then be able to move towards fixing it and then fix it is a big deal.
And while it was happening, I was like, "That's big brain thinking right there."
It sure,
Shout out to Ruby.
it
Yeah,
sure is.
yeah.
It sure is. There's there's so many interesting things that as you get better at all of these skills, you get more advanced. And totally the way that I write code and even the way that I draw 3D models has been influenced by that leave notes for future self, right? Like you're the one who deals, you're the person who's going to pick up the pieces, and you can leave yourself all of the things that will have fallen out of your short-term memory in the comments of your code or in the way that you designed your thing. Your short-term memory is short, and so you're going to lose it. The things that you're like, oh, I'll remember that weird feature, you won't. Like just know that you're not going to, and then write yourself notes of, oh, it's connected to this file, or I need to do this, so this is where I got this weird random seeming number. Those sorts of features I definitely include now, like fastidiously in the code that I write, probably to a point where a professional developer would laugh at what I write for comments. But I think that they're very helpful. And so that's really a big feature to take forward in how you're doing things. Let's see. Anybody else do fun things? Do we have any new carpets? Lila, I feel like a new carpet comes out every week or two.
Now I guess I did make something little for my friend. I wasn't gonna show it, but I can. All right.
Oh, I heard it's big. Ruby just said.
It's not too big, but all right. Did that work?
Yeah. Oh, that's lovely.
I think. Hold on.
Is that it's like it's upside down, but it looks like
There
it's
we
a
go.
pendant.
Yeah. So I made that.
That's like the detail on that is incredible. You really like in the first generations of the carpets, you had a lot of like feature, lines would overlap, but this is so clean.
It was kind. I should have documented more of how I kind of went through the process, but I was kind of wondering, all right, if this doesn't work out, I'm just gonna get her some lotto tickets. But it kind of worked out nicely.
It worked out great.
Yeah.
Yeah, you're really getting better and better at this all the time. It's amazing to watch the skill build as you practice these things.
Yeah, and I was thinking for the make something big, just to do a stool, kind of what Kate made on the Shipoko, or that thing that you showed in the earlier slide. I hadn't watched that video, but maybe alter the design a little bit, and maybe I could like tuft a little fabric top to it, something like that.
Really
cool. Ideas.
Yeah, that would be super neat to have a little like carpeted top on one of those stools for sure.
That's all. Anyone else sharing?
Oh, Kate is saying you should make a flower sort of stool, and then the top can look like a flower petals.
Yeah, I was thinking also like to maybe make it a little more interesting than a circle. I haven't gotten to the details, but ideas are rolling in.
There you go.
Yeah.
All right, cool. Let's see, and then we've got lots of anybody else. If not, we can hop over to, I can just like continue to what I was doing with, oh yeah, we've got more people.
I did just want to say that Lila and me and Ileana got the Gerber badge this week in preparation, which is a pretty big accomplishment, and I highly recommend it. And it was really fun and a little hard, but it feels less scary now. And it was really fun to have them with that. So that's something else they both did.
I definitely feel like lots of this is good to do as a group experience. And it may, like, we're increasingly getting to that point in the course where these things become a little bit bigger projects, and it's good to know, like, this is something I want to do with people. I don't want to be stuck doing this on my own. Man, there's so many cool things that look at all the stuff you guys did this past week. This was one of our best documented weeks, perhaps. That's great. All sorts of cool things. All right, so we've got. All right. Yeah, there's tons of cool things that were done. We're really close to making big things. And so I'm excited to see what happens this week, what sort of different things are going on. Big is definitely open-ended. It is not a specific size. It doesn't mean minimum 4 feet, right? That is not a rule that we've made in any way. So big is big to you, right? You can interpret that as you will. Think about the scale that you want, and we can go from there. Probably we're well past the end of what would be good for recording if we want. Although I've got just a little bit left to get ready for this file on VCarve. We can record that, we can not. It's very close to doing on the Gerber. Sure. Yeah. Here's another trick that I can try and pull. See if this works. We'll do duplicate, and here's this. So now we're all looking at my screen down here, so I'm not like staring at a thing that's all over the place. One of the things that when you're doing all of this, I'm like trying to get all of my designs to work in Inkscape. So here's this, and ultimately I want to get these designs to be sort of like laid out well on the page. So this is me just sort of working on my laptop, like how I'd get prepped for this. All I'm gonna do is take these pieces and sort of get them arranged. And so with this, I've got like the layout of this that I want to generally have. And all I've got are these are the different pieces that it takes to make the little library. And so I'm just trying to line them up into something that's reasonable so that I have less manipulating to do when I'm into VCarve. And so because I find that VCarve is good, it's not like it's bad in lots of ways. I think that moving around vectors is one of the parts of it that I like the least. And so we can just move that 0.25. Whoops, guess I moved it the wrong way. Minus 0.5. I want to make sure that there's enough space between each one of these shapes that I can fit an end mill. And so I'm just sort of like roughly moving them into those spaces, minus 0.25. And maybe I should give a little bit more space than what I've got. All of these, I'm just sort of putting together. Let's see, on the Y, minus 0.25. I can move those around. Yeah, you can do math in Inkscape. Isn't that great? And then all of these pieces, let's see, plop this one into here. I can see that I've overcut that tab. So I want to go down until like those are pretty much there. And then I think for this minus 0.25, whoops, plus 0.5, move it down. So I've got enough space. This has got sort of all of the pieces of that thing all laid out. I'm going to take this and group it and then bring it down to here so that it fits top to bottom. That was sort of a lucky happenstance. When I first did this design, I did not expect that it would all fit that nicely across the top to bottom of a panel. And so we've got that. And then I can take this and paste and do a rotate twice and just line it up over here so that I've got this. Oh, what I also can do, there's these align tools relative to page. Let's do that. Centered relative to the page. This one centered relative to the page. And then these things I've got all lined up. That's totally the designs for two. Good night. That's the design for two of these laid out onto one sheet of plywood. My page is the size of one sheet of plywood. That's totally the two things all put together. So I'm going to grab all of these and make some changes. I need to bring in my strokes. If I go to pixels, I do just 0.02. If I wanted to now, these would be laser cuttable. Those are super tiny, but I'm going to take this and export the page, which is 48 by 96, and export it as I'd like to, instead of a PNG. Oh, that's the only one that it gives us an option. Cancel. Let's see. File. Let's see. Save as. I should be able to save this as, instead of a SVG, I should be able, I like to transfer as PDFs just whenever I can. PDFs, desktop, little free library, and we'll do two design. Hit save. And then okay, I think that's good. And now we pop back over to here. I want to bring up VCarve. So here's VCarve. When you're doing VCarve, you sort of set up the size of your thing, but this is the magic. If you get all these pieces to work, I can import vectors and then little free libraries, two designs, that PDF. And if it does it, boom, there it is. Just imported directly, all those vectors right in their spot. So there's lots to work out here. Like, this is still not done, but you can see I went from Fusion 360 at the beginning of the talk. I was exporting DXFs. Then I imported them into Inkscape, did a little bit of formatting, a little bit of playing, because there's some parts of this that aren't super clear. And then here I've got all of these vectors. The first thing that I'm going to do is a little bit strange. I'm going to go in and grab, there's a handful of vectors that I want to hand address. And it's just because I did something maybe not smart in my design work. But one of the things that you'll often get when you import, yeah, you're good. Yeah. I could have totally just drawn this in Inkscape and then gone straight to VCarve. There's no reason why I had to do Fusion 360 other than I like the constraints and dimensions and all of that. This is parametrically designed, so I should be able to go into Fusion, pop around some of those things, and then just have it work. In here, close, file, import vectors. And I want to do this one. So here's all of these vector files all brought in. If I do this join open vectors, I've got 16 closed vectors and 380 open vectors. In order for VCarve to work the way that it wants, it needs to know what's closed shapes and what's not. And that's a little awkward to be able to tell, but if I hit join, it'll leave 2 open vectors somewhere in this. And so I won't know what those are per se. But what I really want to do is try and make sense of what's happening. I want to deselect a couple of these. From having done this before, let me just do this. Like, I can take all of these vectors in this shape, and I have 4 closed vectors and none that are open. That's great. In this shape, if I highlight that, I've got 5 closed. I've got, oh, this would be after joining. And so I'm looking at this thing over here. It's definitely a little bit weird, but I've got 40 open vectors. That means that those lines that it's recognized and got highlighted pink, it doesn't see them as connected shapes. It sees them as like lines that are there, but they're not touching each other. And so it says that if they're within 4 10,000ths of an inch, join them together. And then when I do that, I'll have 6 closed shapes. This is a weirdness of VCarve. It's taking it's not necessarily storing all of the information that you've got. Like right now, I've got one closed vector. So that one actually imported in just fine. I was trying to do this. What's up?
So, if you were to have open vectors.
Mm-hmm. Open vectors, it won't know how to design for them. So like here, let me do this, and I'm going to unselect a couple of these. Like if I had it be open, here I've got 45 open vectors. And if I said, like one of the toolpaths is, I'd like you to cut on the inside of the lines. If they're open vectors, then it doesn't know what's the inside versus the outside. It'll just pick a side arbitrarily. So by enclosing it, then it can judge what's inside of that loop from the vectors and what's outside. So if I were to take these, and let me do toolpaths, and like, here's this. If I were to do this and say, I want you to do this, cut on the inside and calculate the toolpath, just do calculate, must contain groups with open contours. It just doesn't like doing it if you've got open vectors. If I take the same thing and hit join, and now I selected a shape again and do toolpath, calculate. Other than the depth is wrong, it's not throwing me any problems. As long as I do a depth that's reasonable for what it's got, it would be just fine. 0.75. It should now be happy to make that cut. And yep, it generated a toolpath. So it has to be closed for it to know whether it's going to cut on the inside or the outside. And this is the VCarve file. For a slightly, this is assuming that it's 3/4 inch plywood, which isn't really true. It's instead of 0.75, it's 0.71, which doesn't feel like a big difference. But here, the whole thing is all laid out with only very small differences. If I were to cut this, the thing that you would notice that would be different would be that these holes would be a little bit too big, right? And so these designs wouldn't be right there. But I've gone through and it'll make little cuts with my end mill so that these shapes would all get cut out. There's tabs that are in here. And if I were to go to toolpaths and there's this preview toolpaths thing here, if I were to do this and say, let's turn the speed down just a little, preview all toolpaths, you can see that this is going to show what the end mill will do as it wanders through. Oh, we're going to speed it up. But it will go, yeah. The earlier view where I had all the arrows. Oh, yeah. So this is, that's a good point. Okay, so in here, these are just the vector shapes, right? But if I go into toolpaths, if I start to check these, those are the actual toolpaths that are related to those shapes, but that's the G code where the tool is gonna go, right? So it's gonna trace out that shape to cut that pocket. And so in order to get, like, there's the dog bone that'll be cut. You can see it can go around the inside corner. It'll overcut there. Oops, wrong things. And then if I go to toolpaths over here, I can turn on more toolpaths. Like this is for the face frame. These right here, you can see that's how it denotes tabs. All these arrows, this is to cut out the window to get doors in and out. And then I have another toolpath for the cutout where it cuts out the edges of all of those pieces. Right, and so those are the actual toolpaths laid bare in VCarve, so you can see what they look like. There's a fair amount of fiddling with it to go from the one part of the design to this, and so this would give us a place to start. We can totally cut this on the wood that we have, and it would come out fine. With wood glue and maybe a little bit of shimming, this would all work just fine. This is probably worth it for us to, yeah, let's cut it.
Bye.